An interesting property of the expenditure function is that it's concave in prices. So I have to show that if I pick at a certain price level P right here, right, I'm getting a certain expenditure. The utility here is fixed. And then at P prime, I'm getting another expenditure. This is the least amount I have to spend, right, to get to utility U bar. The concavity means that if I look at a linear combination of P and P prime, P double prime, with P double prime equal to alpha P plus 1 minus alpha P prime, alpha being a number between 0 and 1, concavity of the expenditure function means that E of P double prime U is greater than or equal to the linear combination of the expenditure at the P prime level and at the P level. So this is greater than or equal to alpha E P U bar plus 1 minus alpha E P prime U bar. So the expenditure associated with P double prime is here, right? And the linear combination between E defined over P and E defined over P prime, changing colors, the expenditure is going to be somewhere on this line, right? It's a little bit hard to see, but you can see here that on my graph that this point is slightly higher than this point. This is what I'm trying to show that the expenditure function is concave. I haven't shown you anything, I've just given you the definition. So how do I prove this result? The expenditure associated with P double prime is simply the cost of the optimal bundle, the cheapest bundle to get to utility level U bar when facing the price level P double prime, right? So this is a bundle which is optimal, and this is going to be called the Hicksian demand. So I'm simply going to replace this here by H to show you that this is the Hicksian demand. Okay, it's the cost of the least expensive bundle that gets me to utility level U bar. Now, because of how I've constructed P double prime, right, as the linear combination of P and P prime, this is equal to alpha P times H plus 1 minus alpha P prime times H. Okay? Now look at this expression very closely. This here, P times the Hicksian demand at the price level P double prime, is the cost of the bundle, which is optimal for P double prime, but evaluated at a different price system, evaluated at P. And this here is the cost of the same bundle evaluated at P prime. And we know that the bundle H here is optimal for P double prime, but not necessarily for P or P prime. So this here is greater than or equal to the expenditure level for P to get to U bar, and this here is greater to the expenditure level for P prime, because that's the cheapest cost. That's the cost of the cheapest bundle, and H is not necessarily the cheapest bundle for P or P prime. And so now I've actually shown that this expression here is greater than or equal to alpha E at price level P plus 1 minus alpha E at price level P prime, okay? And this is exactly what I needed to show. I've shown that the expenditure associated with the bundle which is chosen at P double prime, right, the linear combination of prices is indeed greater than or equal to the linear combination of the expenditure functions defined over P and P prime. Now this result, the concavity of the expenditure function, actually plays a role, a critical role later on to show the negative semi-definiteness of the Slutsky matrix. So this is why I wanted to spend the time to derive this result.